All right, so in the last video, we looked at the two levels of problems, like the level one where you set the exponents equal, then level two where you have to mess with the base to change it to make the bases equal, and then you can set the exponents equal. So the next level, the level two of this problem, is what if their bases are not equal and you cannot find a base for the right side that matches the left? So an example is before the power x equals 32. What I should expect to do is look at the powers of 4. So powers of 4, we have 4 to the power 1 equals 4. 4 to the power 2 is 16. And then 4 to the power 3 is 64. Now, I need 32. 32 is a number that exists between 16 and 64. So any exponent that I raise 4 to after this will be bigger than 64. So I need to figure out, what am I going to do here? And the answer is you need to actually affect both sides here. So, and this is where we go back to something that we did in 1C, where we talk about perfect squares. So there are numbers that are the result of taking your regular numbers, your regular counting numbers, and raising them to the second power. So 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, 6 squared. And it's really important that you notice these numbers, that you kind of recognize them, that they stand out as special to you. These are your perfect square numbers, and knowing the first 1 through 10 to the second power actually helps you out so much in your mathematical career. So 4 can be written as 2 to the power 2. And that's going to be super helpful here. So I'm going to take this 4 and just see what happens when I rewrite it as 2 to the power 2. And again, that's also raised to the power x. And that's equal to 32. So here's a 1a thing, right? If I take a power and I raise it to another power, I multiply these two numbers. So I get 2 to the power 2 times x. Okay, now let's look at the two powers, right? Let's look at two different exponents and see if we can get it equal to 32. So I'm going to open up Desmos. 2 to the power 1. 2 to the power 2. Again, no. 3. 4. Get closer. 5. Perfect. Look, 2 to the power 5 is equal to 32. So it works out, right? Instead of 32, I'm going to write 2 to the power 5. Now we have the same base. Each power has a base of 2, which means I could take these exponents and set them equal. The extra step, though, is that we want just x equal to 5. But here we have 2 times x is equal to 5. So we have to undo that multiplying of 2. How do we do undo multiplication? What's the opposite of multiplication? Well, it's division. So I'm going to divide both sides of this equation. This is a integrated 1 skill. Divide both sides by 2. 2 divided by 2 is 1. So I'm going to, cross that out, ignore it. And I get x is equal to, let's just leave this as a fraction for right now, 5 over 2. Okay, so that is the extra step that we inherit here. And here we have another problem here. So 9 will not be raised to any exponent to equal this. So instead, let's rewrite 9 as 3 to the power 2. So I get 3 to the power 2, put it in parentheses, raise it to power x, is equal to 2,187. And remember this, I'm going to rewrite this by multiplying these exponents. So 3 to the power 2 times x. And I want to find 3 to what power equals 2187. So let's go to Desmos. Let's start trying some numbers. Remember, 3 to the power 2 is 9. So we'll keep trying. Keep trying. Keep trying. We're getting there, right? We're getting close. We're in the thousands we need to be. There it is. Perfect. Okay, 2187. So 3 to the power 7 is 2,187. This is 3 to the power 7. Beautiful. So here we have the exact same base, which means we have the exact same exponent, or we have equal exponents, so 2x equals 7. And I will perform the exact same operations, right? I'll get rid of that multiply by 2 by dividing by 2. And I'll be left with x is equal to 7 over 2. And that's how we solve equations involving rational exponents.